Corrosion is the gradual destruction of materials. It is common with metals by the chemical reaction with its surrounding environment. Corrosion is a natural process that can't be completely prevented. An example of corrosion is when steel rusts when it is in seawater. The process of corrosion involves four elements: an anode, a cathode, an electrolyte, and a metallic pad. There are many forms of corrosion. It is usually determined by the type of material, its surrounding environment, and the length of exposure to its environment. Generally, corrosion is a chemical reaction which is easily determined by the appearance of the metals. It is easy to control corrosion and slow down the process, but if not controlled, the metal surface continues to thin until nothing is left. Corrosion does not only happen with iron. It can happen with metals like magnesium, zinc, aluminum, as well as iron. Aluminum, however, corrodes much slower than iron. Redox chemistry is any chemical reaction in which oxidation numbers of atoms are changed. We can also call it an oxidation-reduction reaction. Such reactions are known as redox reaction. Reduction involves a decrease in oxidation numbers, while oxidation involves an increase in oxidation numbers. The change in oxidation numbers are often associated with the transfer of electrons. This is where corrosion relates to redox chemistry. Corrosion processes a reduction-oxidation reaction. In oxidation, the metal loses electrons. This involves an anode. In reduction, the oxidizing agent gains the electrons. When this happens, it involves cathodes. Since corrosion is formed through the oxidation of metals, there must be a presence of an electrolyte for ions to flow and a reducing or oxidizing agent for the electrons to be transferred. The rust usually forms a circle around the outside of the droplet, because it is the only place where the metal is exposed to water and oxygen. The unstable metal, which is the anode, releases its electrons to the oxidizing agent, which is oxygen. The electrolyte will allow the ions and electrons from the oxygen to transfer to the metal. The portion where the metal is covered by the water droplet does not rust because there is no presence of oxygen. Thus, no redox chemical reaction can take place due to the absence of oxygen. One reason why rusting occurs near wheel wells and door bottoms is due to a structure that captures water. When you wash your car, most of the water will run down towards tires, and the concave shape of the structure will capture the water, and it will be there until the tires start moving again. For the door bottom, most of the water deposits there until it dries out. When the car is moving, most of the wind is captured in the area in which allows redox reaction to occur. As the metal is exposed to a great amount of water and oxygen, the gravel on the roads will chip the empty rust coating off the metal. Then, when the tires move, the uncoated metal will react easily, and corrosion would occur. Metal corrosion is a concern as it possesses economic, technological, health, and safety threats to the progress of our society. As metal deteriorates, another metal is put in place. This process of switching to new metals will cost a great amount of money, causing economic trouble as this happens in an increasing rate. Our technological success is being held back by corrosion, as metals are often used for inventions. Healthy and safety risks are also imposed by corrosion, as most prosthetics have metal parts that do not last for more than 3 years. If not prevented or controlled, corrosion will continually be a cause for the loss of money, buildings, roads, pipes, and bridges. corrosion takes place, three conditions are required, and those three namely moisture, metallic surface, and an electron acceptor are altered, can prevent corrosion. Many methods exist in carrying this through. These include anodizing, many types of cathodic protection, coating a metal with non-metal substances, galvanizing the metal, sacrificial electrodes, and an impressed current. The first process, anodizing, takes place when a thick layer of corrosion is developed. By doing this, underlying metals are protected from corrosion. The next method is cathodic protection. This is carried through by placing a continuous negative electrical charge on the metal. This process is similar to sacrificial coating but uses a more active metal. It occurs when two different metals are situated in an electrolyte. This method converts unwanted anodic sites on a metal surface to a cathodic, which is passive site, by using an opposing current. The source that has the negative charge is an external power supply. It can be used to protect pipelines and fuel tanks underground. Coating a metal with a non-metal substance can also prevent the metal from undergoing corrosion. This is helpful because it separates a chemical compound from corrosive materials. This method of coating is not as well known as coating a metal with another metal, such as nickel and iron. Examples of these include electroplating, mechanical plating, hot dripping, and electrolysis. On the other hand, you can galvanize a metal by applying a zinc coat of fabricated iron or steel material and then bathing the substance in molten zinc. During this process, the molten zinc reacts with the iron or steel material to form a series of alloys. Galvanization is popular for its simplicity, low cost, low maintenance, and sustainability, as well as it is one of the most effective methods in the prevention of corrosion and does not get damaged easily. Another added effect is that its byproducts are recyclable. Sacrificial anodes are extremely active metals who attempt to stop less active materials from corroding. The name sacrificial comes from the anodes literally sacrificing themselves for the material they are protecting. To work properly, the anode must have a more negative electrical potential value when compared to the material it is protecting. These anodes are created from metal alloys such as zinc and magnesium, or magnesium and aluminum. They oxidize much quicker than the metal they are protecting, and therefore are consumed completely before the other substance reacts with the electrolytes. Daily life examples of this usage are for water heaters, pipelines, distribution systems, above-ground tanks, underground tanks, and refineries. The final method of preventing corrosion is by impressed current. You can practice cathodic protection by coupling the metal you wish to protect to the negative pole of the direct current source. The positive side should be coupled to the anode. In this particular method, no material needs to be more active than the other, as it is the driving voltage provided by the direct current source. It is another type of cathodic protection, which uses electrochemical means to protect metals against corrosion. This process decreases the difference between the potential energy and the cathodic and anodic sites when put into a conductive electrolyte solution.